Hello, puppets. Welcome to Lens Math.
Yes, lens math. I'm so excited.
Of course you are. Of course you are. It's physics and we're excited. All right, now I've grabbed the AP Physics 2 equation sheet. I want to show you something here. So if we go into the section that says waves and optics, there it is, waves and optics. First equation is our velocity equation for a wave. Second equation down, the third equation down. Third equation is Snell's law. Talking about there. And this equation here is one for index of refraction, when we use that in the lab. And then below that we have the wave equation for distance from an image. Distance from an image equation, that's a fraction one. Now on here, they don't use D's. I use D's for distance, makes sense to me. But AP has always gone and used S's for distance. So S is used for D. And there was a reason why I used to know, but I don't remember anymore. But they do that, they use an S instead of a D. Okay, but that is the mirror equation, right? That's our mirror equation to figure out mirror math. And if we look below that, we have the magnification equation, hi-ho, di-do. They don't put the negative in there. I do. But they should, but they don't. But you have to know that we put a negative in here to help us determine whether or not it's upright or inverted. And then there are two other equations down here. Those have to do with what is called Young's experiment, and we'll go through those. That's important. But for now, you can see there aren't that many optics equations, and we are basically already, even before we do lens math, we're through these. Aha, lens math. We still use the same two equations that we used for mirror math. So lens math is going to be pretty quick here. There isn't a difference in equations. We still use the same ones. So when it comes to distance, we say 1 over di is 1 over f. Of course, you're usually trying to find di, not always. Like on here on the sheet, they have it set up so you can find 1 over f. It's 1 over f is 1 over di plus 1 over do. But I set it up to find di because that's what we're usually doing. So 1 over f minus 1 over do. That's our mirror equation and our lens equation as well. And the magnification equation is still the same. All right, hi-ho, di-do. So the equations are identical. The things we have to be careful of is, with mirrors, if you had a convex mirror, that was the bubble out mirror. So let's do a quick review. So if I had a mirror that bubbles out, and there's my object, all right, and you do a quick drawing, blump, 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 blump. We draw back those rays, we always get an image inside that mirror. And I reminded you of this. This is really important. This is called a convex mirror, but it's also called a diverging mirror and a negative mirror. Negative. Negative Ghost Rider. All right. Tom Cruise, 1986, Top Gun. Good movie. Check it out. So this is going to have a negative focal length because it's in the mirror. This is the virtual side. Here's the real side. This is the virtual side. Negative focal length. So I warned you. I said I did. I warned you. You kids, I warned you. You don't listen to me. What do I know, right? What do I know? So I said put a negative in front of the focal point when you do the math on a convex mirror. We got to think the same thing when it comes to lenses. We have to remember that. Now with the lens, if we have a diverging lens, then a diverging lens, okay, here's my lens drawing set up for any lens drawing. We set it up like this. We went through 3 of those things with you. I did 3 examples of lens drawings. So we always do the same setup. And if it's a diverging lens, let's say I have an object here, and it's diverging, I'll go parallel focus toward this focus, parallel, we'll get an image here. Where's my diverging lens? Here it is. Diverging lens. And that's the one where, oh, it makes my head look real small. That's because you see that, and that's the top of my, here's my head here, and here's my head here. Okay, so what that means is if it's diverging lens, that's the same thing as a concave lens and a negative lens. All 3 names can be used, negative lens, because we have to remember when we do the math with a negative diverging concave lens, that the focal length is going to be a negative. It's a virtual lens. So So I have to remember that. Jot that down somewhere, okay? Because you're not going to remember it when you're doing it.
Oh, yeah, well, I'm smart. 2 weeks from now, when I'm doing my test, I'll remember this.
Really? Write it down. So, diverging lens, concave lens, negative lens. When you're using one of those, put a negative in front of the focal length. Otherwise, you'll miss it all up. All right, so that's the thing to remember about lenses. Otherwise, if it's a concave lens, it's a positive lens, so you just go ahead and you put the focal length in and do the math, just like we did with mirrors. And when it comes to magnification, it's the same thing. Hi-ho. Oop. Hi-do. Hi-ho. Di-do. I put the negative in. The AP equation doesn't have that. It's okay. I mean, you don't have to, but I put the negative in because that way when you do the math on it, if it comes out positive, then you know it's an upright image. If it comes out to be a negative answer for your magnification, it's an inverted image. This just kind of helps you out there. All right, that's it. That's basically it. The rest of the math is done the same way, same equation. So just be careful of that one little trip up. That negative, remember that negative if you have a diverging mirror or a diverging lens. Okay, kids, see you on the flip.